Hello guys, so we're going to look at question 2 on the probability review sheet. We're told the spinner is spun 150 times. How many times does it land on section 3? So the first thing is we're going to see that there are 1, 2, 3, 4 different 3s on this board out of a grand total of 10 different sections. So the probability of getting a single 3 is 4 out of 10. Now I'm going to simplify that to 2/5. So that's the probability of getting a single 3. And now we're going to multiply it by 150 since we're going to be conducting 150 trials here. And that will tell us about how many we could expect. Cross canceling here, 150 divided by 5 to get 30 times 2 or 60 would be what we could expect. That doesn't mean we actually get 60 different 3s if we actually spun 150 times, but it is a reasonable estimate. So 60 for number 2. All right, for number 6, we're told compound events here. We're rolling a die and flipping a coin at the same time. And we want to know what's the probability of getting heads and the die landing on a 4. So we're going to find the probability of each. A heads is 1/2, obviously, and a die landing on 4 is going to be 1 out of the 6 total sides. Now we can multiply this together since they are independent events to get our answer very quickly here of 1/12. Now there's an alternative way to do this one as well. Sometimes with compound events, they can be a little tricky. Tree diagrams definitely come in handy with these. So we can see the different outcomes for flipping a coin, a heads or a tails. And then our 6 branches for obtaining, the 6 sides of the die here. I can get a 1, 2, 3, 4, 5, or 6. Tree diagrams are obviously just a little bit more of a visual approach to a probability question. Helps you see all the events come into play. Just copying and pasting here so I don't have to draw the 6 branches again. And when we're all said and told, we can really see where the number 12 comes from here. Basically, think about following the end of each branch, 6 and 6, tells me that there's 12 total outcomes. And there's only one desirable result. I'd obviously have to go up for heads, and then to the 4, there's only one way for me to get a heads and a 4. So 1 out of 12 is where we get our answer of 1/12. So this is a compound probability question, independent events, multiply probabilities, probably the shortest and most efficient way of answering this question. All right, for question 10, we're simply just reading a box plot. We're going to identify the 5 stats summary for class 1 and class 2. This is a double box plot. So we see the 5 different dots. It's important to know which one is which here. For class 1, our minimum is going to be the point furthest to the left. These are, some people call box plots box and whiskers. Your min and max are always going to be your whiskers. So the 0 and the 50, furthest to the left, furthest to the right. Q1 is going to be the left side of the box, that's 30. The median is the drop down of the middle of the box for 40, and quartile 3 is your right-hand side at 45. IQR, standing for interquartile range, is going to be Q3 minus Q1 to give us an answer of 15. And now the same thing for class 2. We're going to get 15 for the minimum, furthest left. Max, furthest right, is 70. Q1, 30. Median, that drop down line in the middle of your box, not necessarily the middle, of 40. And the right-hand side of the box is 60 for quartile 3. And now if we find the difference between our quartiles, we get 30 here. Quartile 3 and quartile 1, I should say. 60 minus 30 is 30. So also important with box plots to remember the percentage breakdown. You see me writing 25, 25, 25 up there. They are called quartiles because they break the data up into intervals of 25%. We know the median is the middle, so it makes sense that this is the 50% mark. But the other quartiles do the same thing as well. Quartile 1 is the 25% mark. That means 25% is less than that value, and 75% is on the right-hand side of that value. We can say the same thing, vice versa, for quartile 3. So it's important to understand that percentage breakdown as well as reading the different values from a box plot. All right, in question 11, we're told that there's 3 colored sections and they're not of equal size, meaning this is not equally split up into 1/3, 1/3, 1/3. We don't know what the board looks like. So this is going to be experimental probability. In other words, we're using the results to create the probability ourselves. So the probability of getting a red, we know that there were 15 successes. Where am I getting the number 50 from here? It's adding up 12, 15, and 23. I'm going to simplify that by dividing by 5 to get the probability of a red to be 3/10. So again, this is experimental probability. We need some type of data, we need results, and we're going to create the probability based on that. Had this been an equally spaced out board, the answer would have just been 1/3. But based on what we know in this large sample of 50 different spins, we're going to assume the probability is somewhat close to 3/10. And the last question we're going to look at here is question 15. We're told 5 equally sized sections were used in a spinner game. It landed on section 4 90 times. We're going to spin it 140 times the next round. How many times do we think it's going to land on section 4 now? Now, the probability of it landing on section 4 is actually going to be a little bit of a trick here. It's simply going to be 1/5. Now, why is this a trick question? Because the 210 and 90 actually doesn't come into play here at all. We're not going to be utilizing that experimental probability. If they're 5 equally sized sections, the probability of getting something is 1/5. Now, just like other prediction or estimation questions, I'm going to multiply that by the number of trials I'm going to conduct, and that should tell me the expectation. So 1/5 times 140 is very simply going to be 28. So once again, this had somewhat of a slight trick in it, in the sense that sentence 2 we could have crossed out from the very beginning. We don't need any experimental probability like question 11 because we know that they're equally sized. We know the probability of getting a 1, 2, 3, 4, or 5 is simply just going to be 1/5. It would be very similar to like a rolling a dice question or something like that. If you're having trouble understanding why it's 1/5 and why we're not using 90 over 210, think about me flipping a coin 10 times. I might get a heads 9 out of 10 times. That doesn't mean the probability of a heads is 9/10. The experimental probability is 9/10, but when I flip that coin on the 11th time, it's still a 50-50. It's still 1 over 2 that I get a heads. So a little bit of a trick question in number 15. An estimation, still it's a prediction. We don't know if we'd actually get 28, but based on all the data here, 28 is a reasonable estimate for the number of times we would land on section 4. Thank you guys for watching this quick little video. Hopefully this will get us used to Edpuzzle. We'll be using it over the next few weeks for our video lessons. And this was just a sample of some of the questions on your review sheet. I tried to do some of the trickier or harder ones. The rest of the solutions will be posted as a PDF. Enjoy, be safe, and take care.